Hi everyone, Mary here, and we're going to do another kinematics example problem. And this one is going to involve multiple parts where motion is going to change throughout the problem. So let's go ahead and go through this. A motorist drives north for 35 minutes at 85 kilometers per hour and then stops for 15 minutes. He then continues north, traveling at 130 kilometers per hour for 2 hours. What is the total displacement and what is the average velocity for the entire journey? Now this problem is complicated enough that I am going to feel a lot more confident if I draw a little bit of a picture. So here's my little car, and yeah, it's not a great car, but that's my little car. And this person is going to drive for 35 minutes at 85 kilometers per hour. So velocity is 85 kilometers per hour for a time of 35 minutes. And I'm going to call this part 1 of the journey. Then this person is going to stop for 15 minutes. So the velocity for this section is going to be 0. The driver is going to stop. The time is 15 minutes, and we're going to call this part 2. And then part 3 of the journey, he then continues north, traveling at 130 kilometers per hour for 2 hours. So now the velocity is 130 kilometers per hour for a time of 2 hours. And I'm going to refer to this as part 3 of my journey. The question is, what is the total displacement? Well, total displacement is going to be the distance covered in part 1 plus the distance covered in part 2 plus the distance covered in part 3. So I have to figure that out. So let's go ahead and do that. For part 1, I've got velocity, I've got time, I don't know displacement, but I do have an equation for velocity, distance, time, and that equation is velocity is displacement divided by time. And before I can use this equation, I look at my data, my time and my velocity, and I have a challenge. And the challenge is, this is kilometers per hour and this is minutes. So I've got to have my time units in the same type, all minutes or all hours, before I continue. And I think what I'm going to do, because this is kilometers per hour, this is hours, this is minutes, I think I'm going to make everything minutes. So I'm going to take a moment and convert this time to hours. So if I've got 35 minutes, set up a little TIE fighter, get rid of minutes, go to hours. I know there are 60 minutes in 1 hour. That's going to cancel, and then the time for part 1 then is going to be 0.583 hours, and that's going to be my time for 1. Okay, now that I've got my hours and hours, I've got my units cleaned up, I can go back and use my straight line velocity equation here. And I'm solving for x, so I'm going to have to do a little algebra. My algebra is, I'm going to multiply both sides by t, and that's how I'm going to get rid of t. You do something on one side of an equation, do exactly the same thing on the other side, and you're going to be okay. So displacement will be velocity times time. So let's throw the numbers into the equation. My velocity is 85 kilometers per hour times a total time of 0.583 hours. And where did I get that? I got that from right up here. That's where that time came from. Hours are going to cancel hours. One's on top, one's on the bottom. I'm going to end up with a displacement in kilometers. And for the very first section, my kilometers is going to be 49.6 kilometers, is when I round this off to 3 significant digits. Now in part 2, the driver has stopped. So how far is he going to travel while he's stopped? Well, that's going to be 0. That's easy. I can figure that part out. For part 3, he's going 130 kilometers for 2 hours. So how far has he traveled? Well, I'm going to use the same equation. Displacement is velocity times time, 130 kilometers per hour times 2 hours, And so my total time is going to be 260 kilometers. Hours cancels hours, and I keep kilometers. So back to the question from Part A, and Part A said, what is my total displacement? So in Part 1, I actually traveled 49.6 kilometers. Part 2, 0 kilometers because the car was stopped. And Part 3, 260 kilometers. So my total displacement for the entire journey is actually going to be 310 kilometers when I round it off to 3 significant digits. So that is the answer to Part A. Now Part B says, what is the average velocity? Okay, average velocity. How the heck are we going to do this? For average velocity is going to be the entire change in displacement divided by the entire change in time. Well, this happens to be my entire change in displacement. My change in time is going to be equal to my total time, and my total time is going to be the time from Part 1 plus the time for Part 2 and the time from Part 3. So my total time, Part 1, it was 0.583 hours. Time 2 was 15 minutes, and I said I was going to do it all in hours. So 15 minutes is what fraction of an hour? Well, I can do that in my head. 15 minutes is a quarter of an hour, so it's 0.25 hours. So that's 0.25 hours. And then Part 3 is 2 hours. So when I add all those together, time total ends up being a grand total of 2.83 hours. That's my total time. Now that I've got total time and I've got total displacement, I can now calculate average velocity. So I'm just going to move this down a smidge and grab another ink color so we know it's a new part of the problem. So average velocity is going to be my total change in displacement over total change in time. My total change in displacement was 310 kilometers, 2.83 hours. And when I do the math, I end up with an average of just about 110 kilometers per hour. That's average, not instantaneous, but that is over the entire displacement and the entire time. You're going to encounter multiple homework problems that are going to have parts and bits and pieces and this concept of average. So I hope this helps. See you next time.